Hello, welcome to MyMathYourMath. Today we're going to talk about domain and range. It's something that I know a lot of people love to do, so that's why we're talking about it today. I have two examples, A, B, and they're going to be over here, A and B as well. This side we're going to take the domain, this side we're going to talk about the range. Now the domain is it's always actually the x values that you're allowed to plug in to get an answer. And it's usually all real numbers for a lot of the polynomials that you're used to. For example, x squared plus 1, the domain is all real numbers. Let's say 2x cubed minus 8x squared plus x. The domain is still all real numbers. And by that, we just mean all the numbers from negative infinity all the way to positive infinity. And another way of writing that, I don't know if you guys have ever seen, but it's an R with an extra line going through it like that. Okay? So the domain for these guys, it's nice. It's all real numbers. However, whenever we want to find the domain of a function where there's a variable in the denominator, or a function where there's a variable inside the square root, such as example A, and in example B, you see the rational function. These two, the domain is not necessarily always all real numbers, and also the range is not even all real numbers usually. Okay, so let's talk about A first. So it's a square root. Now the general rule is you always want what's inside the square root to be not negative. To be not negative is the same as setting it greater or equal to 0 and solve. So 2x minus 4 is greater than or equal to 0. Adding 4 to both sides, we get that 2x is greater than or equal to 4. And that means x, when you divide by when you divide both sides, by 2, you get x is greater than or equal to 2, which is the domain for this one. Okay? And another way of writing x greater than or equal to 2 is all the real numbers greater than or equal to 2, which is bracket, because you're including 2. This is the set notation that a lot of teachers ask for, comma, all the way up to infinity, and always parentheses around infinity. Okay? So this is another domain answer, and this is one domain answer for A. Let's look at B now. So in B, all that we care about is for the denominator to not equal 0. So we take the denominator, we set it not equal 0. So if x minus 1 is not equal to 0, that means x is not equal to 1. That's the domain for this one. All real numbers x except for 1. And the set notation way of writing it is you look at negative infinity to positive infinity and you poke a hole at 1, all right? Now watch. You go from negative infinity all the way to 1, poke a hole there, that means we're not including 1, and we're unioning from 1 all the way to infinity is the other domain answer. So this is the set notation answer, and this is the, I don't know what you would call it, but the other answer. All right, and then for range now. When you have a square root, typically the range is going to be all non-negative real numbers, okay? So square root functions, unless if there's a shift on the outside. So this one has no shift on the outside. So for example, if there was a number, let's say 1 here, then this would be all real numbers greater than or equal to 1. All real numbers y greater than or equal to 1. In our case, there's a 0 there, so the range is y greater than or equal to 0. And the set notation is from 0, bracket, because we are or equal to. If this was just y greater than 0, not the or equal, this would have been a parentheses. And this goes all the way to infinity. I guess these are the range answers here. Last but not least, this is probably one of the more tricky ones. Whenever you have a rational equation and you'd like to, or a rational function, I'm sorry, and you would like to find its range, this is the trick. So this thing is equal to y, correct? Right, y equals this thing. And the trick for finding it is now in this equation, you see how y is by itself? We're going to get x by itself. Isolate x. So that means multiply both sides by x minus 1. Okay, so it cancels over here. So it becomes y x minus 1 is equal to 2x. I'm going to go ahead and distribute my y. So I get yx minus y is equal to 2x. And we want to get x alone. So I'm going to add a y to both sides and subtract a 2x from both sides. And I get yx minus 2x equals y. Factor out an x. And divide both sides by that parentheses, y minus 2. So we get x equals y over y minus 2. And now we do the same trick as we did in the b for finding the domain. We look at the denominator, set it not equal to 0. If y minus 2 is not equal to 0, that means y is not equal to 2. Is the range here. And we're going to go ahead and do the set notation for that as well. So we're going to start from negative infinity. We're going to go all the way to 2 and union from 2 on to infinity is the set notation for the range for example B. And that is domain and range.